This is Vampyronassa rhodanica, the vampire fish trap that lived over 160 million years ago in the middle of the Jurassic. The picture is artist Franz Anthony's recreation of the cephalopod. Notice the long thin head or mantle, the webbing between the arms, and the extra long front pair of legs. I had a bit of trouble with finding the information for this slideshow because really the only information on it is a French paper which described and classified it. After putting it through Google Translate and working out what bad grammar was left, the paper turned out to be incredibly informative and exactly what I needed. The vampire fish trap is part of order Vampyromorpha, which looks like something between octopods and squid. Its genus name, Vampyronassa, comes from the Serbian vampir for the cape-like vellum between its arms and the dark red coloring of its living equivalent. And nassa is Latin for net of fish. The species name rhodanica is for the Rhone basin where the specimens were found. About 20 specimens were found in a sediment deposit that I'm not even going to try to pronounce in France in the 1980s. The fossils there are generally preserved through pyritic mineralization, and the preserved organisms in the lower Cavallonian there lived at about 650 feet below the surface of the ocean. That's in the aphotic zone where sunlight does not reach. The longest specimens nearly reach 5 inches long. They wouldn't even be as long as your smartphone. If you're watching full screen on a desktop computer, most of these images will be near life-size. Order Vampyromorpha has several clear characteristics which separate it from other cephalopods. Their internal shells, called a gladius, are uncalcified. They have 2 light-producing organs in their back, but no ink sac. They have a pair of fins on either side of the back part of their head. They have 8 arms united by a web, with 1 row of suckers and a row of finger-like cirri on either side of the suckers leading up to the mouth. They have brachial tentacles, a sort of pair of modified arms, and a well-shaped eye on either side of their head. There's only 1 living species in this order, Vampyroteuthis infernalis, the vampire squid, but there are other extinct species, like our vampire fish trap. The vampire fish trap has differences that can give us clues to its life when compared to the living vampire squid. Its first pair of arms are longer and stronger than the rest, unlike the vampire squid. Its mantle is thinner and longer, its siphon is bigger, and it's generally more muscular. Based on all of this, it's inferred that the vampire fish trap was a strong swimmer that likely actively hunted in the ocean and higher up than the vampire squid. They are similar, but their differences are enough to give them different genus classifications. Grace E. Pickford was something of a vampire squid expert, and in 1940 she described it as a living fossil, just like many other deep-sea organisms. Life does not evolve much in the deep sea because it's stable down there, and not much changes, so why should the creatures? Because of this, comparing the vampire fish trap with the vampire squid is perfectly reasonable. Knowing how the living behaves is useful for understanding the extinct. Vampire squid aren't actually squid, they just look enough like them to get that common name. They're about twice the size of vampire fish traps and can reach about a foot long. They're generally described as a dark red, but that is in the light of remote vehicles. A long time ago, an expedition once hauled up one from the ocean, and it was described as a very small but terrible octopus, black as night with ivory white jaws and blood red eyes. Cephalopods are generally active hunters, but this one is a passive detritivore. They drift around catching the plentiful marine snow and the occasional shrimp or something else. They have very slow metabolisms and don't move much. Because of this, it was believed for a long time that they were not strong swimmers, but their quick, agile swimming has since been videoed by submersiles. It isn't fully understood yet, but when they are threatened, vampire squid will flip their arms over their mantles. They may even be able to see through their vellum. Being animals that live in the dark ocean, they have bioluminescence. The ends of their arms glow, and by waving their glowing arms, they confuse their predator. Flipping inside out probably helps too. They can also put out bioluminescent mucus, like ink and other cephalopods, and disappear into the darkness. Vampire fish traps also lived in the dark and had light organs, so this behavior may have been similar. Brachial tentacles on vampire squid are also a little mysterious. They are sensory filaments that they can either extend out or retract into a pouch. So far, it seems that they aid in food detection or retrieval. Food particles in marine snow are caught by the stiff hairs on the filament and can probably be taken off and led to the mouth by the cirri. Of the 20 or so specimens, only one showed any sign of brachial tentacles. It is not known if they had sensory filaments or something else, but it is thought that they probably had a pouch like the vampire squid to tuck that brachial tentacle into, which prevented clear preservation. The living vampire squid lives about 2,000 to 4,000 feet below the ocean surface. But the vampire fish trap would have lived only about 650 feet below. Active hunting was probably a more favorable lifestyle higher up, and that then being a strong swimmer would have made them more fit for living up there. An advantage in a dark environment would be a big eye that could still see in the dark with whatever method, and the vampire squid has that. They have the largest eye-to-body ratio of any animal, and the vampire fish trap specimens also show evidence of big eyes. The small size of the vampire fish trap was likely favorable just like active hunting. But fun fact, judging by the varying specimen length, their size was probably sexually dimorphic like the vampire squid. The females are bigger than the males. Thanks for listening.